Find the local maxima and local minima, if any, of the following function. Find also the local maximum value and local minimum value. So we have g of x is equal to 1 by x square plus 2. So the very first thing is we have the inverse relationship, and we need to recall that the behavior of x square is a smiley face. The inverse you can imagine. It would be positive value, but it would never touch or it will never grow, right? I hope that made sense. If not, I'll show it, of course. We'll discuss that as well. Graphically, that's what I mean. Okay, let's observe this behavior using our arithmetic and algebra. So x square has to be a value which is greater than 0 always. Now we need x square plus 2, right? That's the closest we can get to. So we're going to add 2 on both sides. And then we have x square plus 2 greater than or equal to 2. We have to invert it. So we'll invert both sides. And so we have 1 by x square plus 2 and 2 over here. What will happen to the symbol? Yes, the inequality will flip. But why does it flip? Right, the flipping happens because of the following explanation. I can give this. 4 is greater than 2. 1 by 4 and 1 by 2. If we compare this, 1 by 4 is 0.25 and 1 by 2 is 0.5. 0.5 is clearly greater than 0.25. So with that understanding, you will be able to understand this. Okay, now one more thing. See, the denominator will never be 0, right? As the denominator will never be 0, and also it will never be, the maximum value is infinity. So the denominator is, right, let me do this actually. How will I put it across? Just a second, I'll just think of it. Okay, so I want to put it this way. X square as x square plus 2 is always greater than or equal to 2, right? 1 by x square plus 2 will always be positive, or let me put it this way. As the expression as x square plus 2 is a positive value, 1 by x square plus 2 should always be greater than 0. And so this particular expression is bound between 1 by x square plus 2. It's always greater than minus, sorry, not minus, it's always greater than 0, but always less than or equal to 2. The maximum value it can go is 2. Minimum value is not 0. For the reason being, 0 is obtained only if this value is infinite. 1 by 0 is approximately equal to 0 but never reaches 0. The graph will never reach 0. Let me show that. So you can see it is 1 by x square plus 2, the same expression. So we can see that the maximum value is half, right? We can clearly note from here. Oh, my bad, this is 1 by 2. 1 by 2, we invert on the right hand side also, na? Inverting both sides, I missed this. 1 by 2, yeah, half. And we can see that it always approaches 0, right? But never reaches 0. Asymptote, if you guys remember the terminology. If not, it's okay. So it always approaches 0 but never reaches 0. Right guys? So that's what I have done over here. Okay. So let me complete the answer. So we have to find the maximum and minimum value. So here we can find the maximum value. From this we can infer that g of x maximum value is half, and the maximum location or local maximum. So we have local maxima. How will you find that? Equate this to half. 1 by x square plus 2 is equal to half. So only way this is possible is x is equal to 0, right? So local maximum x is equal to 0. Okay, so that would be your answer. There's no local minima, so we can't have, because, well, there's no definite value, and so there's no minimum value. There is a maximum value and it occurs at 0. Okay, so that you can verify over here as well. So for an input value of 0, my output value is half, and everything else will be less than 0 or half. Okay, you can pause and have a look.